Okay, ladies and gentlemen, what you're asked to do in this next type of problem is I am giving you a function. In fact, we're going to look at 1, 2, 3, 4, 5 of them in this video. I'm giving you a function and I'm asking you to describe how this function could be graphed using the library of functions. Now, in this top equation, y equals x squared plus 3, the 3 does not go with the x. The 3 obviously goes with the x here because it's in parens. Well, if the 3 doesn't go with the x, that means it goes with the y. It affects the y value. So what's basically happening on this first graph is I'm taking the original graph of x squared and I'm moving it up 3 units. So what we're really doing is we are taking x squared, the graph of y equals x squared, and we're going up 3 units. So it's the y value that's being affected. And remember, y equals x squared is a basic parabola. Now here, y equals x plus 3 quantity squared. This is affecting the x value, so that means I'm either moving to the left or to the right. The thing with x, which is kind of weird, and if you wanted to cheat, when I did this in class, I said go ahead, put this in your calculator and see what happens. What actually happens if you type this in your calculator is the original graph y equals x squared you start with, and you are going to go 3 to the left. Now that's confusing sometimes because you see a plus 3. The plus 3 up here was the y value, and that did exactly what it should have done. The x value, when the 3 is being added to the x, it does just the opposite of what you're thinking. And a really cool way I try to tell my students to remember that, if you were almost translating the origin to back to where it belonged, what would make this become 0? Inside here, and that would be a negative 3. So in your brains I want you to think of that and say 3 to the left. Another way to remember it, when you're moving along the x-axis, it always does it backwards. A minus goes to the right, a plus goes to the left. Okay, when I have y equals x squared but I put a negative 1 in front of it, what this negative 1 is doing is it's multiplying all these y values by negative 1. So the ones that used to be positive are now negative, and the ones that used to be negative are now positive. So what it's basically done, okay, what it basically does whenever you're multiplying the y value by a negative 1 is it turns the original graph upside, let's get it to right, upside down. Another way to say it, think about this. If you have a parabola that this is your basic library. If you multiply by negative 1, all of these positive values become negative. This would be my new graph. And this graph is a reflection with respect to the x-axis. So another way to say upside down is a reflection with respect to the x-axis. And what I want you to get in your brain is this. If I start with the function f of x, but then I multiply by a negative 1, what I'm getting, this new function, the opposite of f of x, is always going to be a reflection with respect to the x-axis. When the original function gets multiplied by negative 1, that's what we're going to get. Now, 2x squared. Okay, this doesn't change the direction because 2 is still positive. But what it does change is it changes how quickly the graph rises. Another way to describe it is it changes what the branches of the parabola look like. Now you know it's a parabola because of the squared. If you want to cheat and type that into your calculator, go ahead and get your calculator out. For y sub 1, I want you to put in y sub 1 equals x squared. Now for y sub 2, I want you to, go down to y sub 2, go down to the, function below the first one, and type in 2x squared. And when you hit graph, you're going to see what's happening. This graph right here is going to be narrower than the first graph. So the number in front, when it's bigger than 1, one way to describe it for a parabola is it makes it a narrower graph. Another way to describe it is it stretched it by a factor of 2. Think about me standing, up in front of you and putting my arms like a parabola. Kind of that U shape. And then you multiply by 2. What you're really doing to get the new graph is you're pulling up on my arms and you're saying, hurry up, you need to get up there twice as fast. And by doing so, you're stretching me by a factor of 2, which is making my graph narrower. Okay, the last one in this example. First of all, the minus in front means we're turning it upside down. The plus 5 means we're moving it up 5, and the x plus 1 in parens, remember, it always does backwards. It is going to move the graph 1 to the left. And the squared, of course, means we're starting with a basic parabola. So what's happening here is you're going to start with y equals x squared. All right? You're going to start with y equals x squared. You're going to move it... You're going to move it 1 to the left, 1 to the left. You're going to turn it upside down, and up 5. So each one of these, okay, has its purpose. The minus reflects it with respect to the x-axis. That means upside down. Squared meant it was a parabola. X plus 1, 1 to the left, plus 5, up 5. And we're done.